Sorry, forgot I was in the wrong room there for a second. Okay, linear quadratic non-function units, lesson 3. We're still on conic sections. We've looked at the parabola. We've looked at the circle. Now it's time to get into one of those more difficult shapes, the ellipse or the hyperbola, as we saw in that overview presentation. They have a few more things to them. This particular lesson, lesson 3, is on the ellipse. So let's get started here, shall we? Okay, again, some of this is already pre-animated out, so I got to kind of think what's going on. The definition: all the points in a plane in which the sum of the distances from 2 points, called the focus, is constant, is an ellipse. So I have 2 points, and I keep the exact same distance between. All right, if I measure from a point to those 2, and I take that distance and I add them up, that's always going to be the same no matter what. And it gives us kind of an oblong shape. We have 2 sets of information because the parabola can be vertical. No, it's an ellipse, can be vertical or horizontal. I've got to fix that right now, please. Okay, fixed it. Had to do it. Couldn't handle that. Okay, so the ellipse can be either vertical or horizontal, which means the rounded shape can either be longer going vertically or horizontally. Okay, general form. Notice horizontal and vertical look the same. Unlike the parabola, where we could see that there was a single x squared or a single y squared, and they would help us figure out the direction. The ellipse, we cannot determine direction just on the general form itself. We can identify that it's a ellipse, but we can't figure out which direction it's going. We have to get it into standard form first. Now here's the thing. Notice standard form for both equations looks almost identical. It's x minus h quantity squared plus y minus k quantity squared equaling 1 on both sides. The difference is here in the bottom. I got a b squared and a squared if it's vertical. I got an a squared and b squared if it's horizontal. Now here's the thing to note. I got it right across the bottom of the screen here. A is always the larger value. So when I get it into this form, there's going to be a bigger number on the bottom of one of these 2. That bigger number tells me if it's horizontal or vertical, depending on which number it is under. Oh, I just lost my mouse. Where'd it go? Down, down, down. Here we go. Okay. So where can we take this to? Important components of the ellipse. We have to have direction. We have horizontal or vertical. Which is the longer way going? We have a center. That's the little blue dot. That's always going to happen. There's the foci. Those are the 2 points that we're measuring our distance from. From those 2 points, the sum of that distance is always the same. We have major vertices, sometimes called vertices, and they're the endpoints of the curves at both ends. We also have minor vertices, also sometimes called co-vertices. They're the smaller ones. They're closer to the center point. We have the equation of a major axis. What is that equation for that direction? We have an equation of the minor axis. We have a length of the major axis. We have a length of the minor axis. So there's a lot of things here, and we have to figure out eccentricity. Remember, eccentricity is a ratio of distance. From the center point is the ratio of the distance. The center point is from a focus compared to the distance that focus is from a vertex. So how far away is the focus from a vertex? That's what we're looking at. As far as the center to the focus. This will always be less than 1 for an ellipse. Again, as we talked about earlier, for a circle, the eccentricity is 0. And what else doesn't want to work? And it refers to how round the object is. Okay, so again, we had our general form of the equations. The general form is extremely useful in us figuring out where everything locates. Okay, as we figured out direction, we have a vertical and we have a horizontal. Note, A is a larger value. So what you do is you look for the larger number. Which variable, x or y, is that number under, is the direction of the major axis. So if the bigger number is under the y, it's a vertical graph. If the bigger number is under the x, it's horizontal. So that's the first thing. Okay, the center, both cases, HK, just like the circle. The foci, H, K plus or minus C, H comma K plus or minus C, H plus or minus C comma K, depending on which direction it is. We're going to add a C. Now here's the thing to note. For the ellipse, B squared plus A squared equals A squared. Or if you want to think about it, A squared minus B squared equals C squared. It is not the Pythagorean theorem when we talk about the ellipse. When we get to the hyperbola, we'll find out that it does work out to be like that theorem. But here it does not work that way. A squared minus B squared equals C squared. C is going to be smaller than your A unit value. Major vertices, I'm going to add the A's. Foci, I added the C's. Notice everything happened to just the K's or whatever. So the majors happen to be in the same direction. So since it was vertical and the A was under the Y's for the vertical side, the C and the A got added to the K value. When it was horizontal, the bigger value was under the X, so the C and the A had to be added to the H value. Now when I go to do the minor vertices, I got to use the B, and I'm going to put it on the other ones. It has to be on the other ones this time around. Equations of the major axes are X equals H if it's horizontal, and Y equals K if it's X equals H if it's vertical. That way everything stays going straight up and down. And on the equation of the major axis for horizontal is Y equals K. And then the equation of the minor axis are just the opposites. So if it's X equals H, it's a major, Y equals K has to be the minor. If it's Y equals K is the major, X equals H is the minor. Why is that? Because the minor vertices, the H can't change from the center. If it's vertical, the K can't change from the center. Kind of a way to help you remember that. Okay, if you need to get all this written down and I'm going too fast, go ahead and pause the video. Okay, continuing on. We have others. We have the length of the major axis is 2 times whatever the A value. The length of the minor axis is 2 times the B value. Eccentricity is C divided by A. And that's why it's always going to be less than 1 because A is always the bigger value. Okay, so let's get through this. Find the important components of the ellipse with the given equation, then graph the ellipse. So I have it all written out. Just like the circle, I'm going to move the number to the other side, collect my x's, collect my y's. Right? So I did that. Now I've got to do my completing of the square. Notice with the y's, I factored out the 2. And now I can work through x squared minus 6x plus 9. So it means I got to make sure I add a 9 to the other side. I had the 4 inside there. I got a 9. And notice I have a 2 times 4 over on that far side because there was a 2 outside the y. So now I have an x minus 3 quantity squared plus a 2 times a y plus 2 quantity squared equaling 16. Now, here's the difference between the circle and the ellipse. With the circle, I divided to get rid of the number in front of the x quantity squared and the y quantity squared. With the ellipse, I have to have the equation equal to 1. I have to divide by the 16. So if I divide everything by the 16, I end up with x minus 3 quantity squared over 16 plus y plus 2 quantity squared over 8 equals 1. Where is that larger number? That larger number is under the x. That tells me this is a horizontal ellipse. Okay, so after you got it in standard form, you got it equal to 1. Now we can find the direction. A is a larger value. That's what I was just talking about. I don't know why that equation's in there. We'll get to that in a minute. Which is a variable under? It's under the x. So it has to be horizontal. The center is HK. I don't know where my center went. Okay, so it's 3, negative 2. The foci, I'm adding the C. Well, where did that number come from? Well, remember, the C is, wow, a squared minus b squared. 16 minus 8 is c squared. So 8 is c squared. So the square root of 8 is c. And if I do my simplifying of radicals, I get c to be 2 squared is 2. Notice it's h plus and minus c comma k. I get 2 points for the foci. So I'm going to take the 3 plus 2 squared roots of 2, and I'm going to take the 3 minus 2 squared roots of 2. I went to a decimal point to make it easier to graph. Major vertices, I'm adding and subtracting the a value. The a value was 4 because a squared was 16. So I got 2 points. Minor values, I'm adding the b value. The b is the 8. So, sorry, b squared is 8. So b is the square root of 8. So again, it's the square root of 2 over 2. Again, I went to decimals. The major axis is y equals k. So it is y equals -2. The equation on the minor axis is x equals 8. So it's x equals 3. Okay. Other thing, the length of the major axis is 2a. So that means it's 2 times 4, it's 8. The length of the minor axis is 2b. So it means it's 2 times square root of 2, or 2 times square root of 8, which is around 5.6. Eccentricity is c over 8. That is 8, or 2 square roots of 2 over 4, or square root of 8 over 4. And if I reduce that down, about 0.71. So I have all the important information. So let's right there. So now I want to get into graphing. So the first thing I do is I draw in my two axes, my equation, my major axis and my minor axis. Those are the two lines. Now I know most of the stuff is going to go on the green because it's horizontal graph. I go ahead and I plot my center point right where the two lines meet. I go ahead and put on my foci. I go ahead and put on my major vertices. I go ahead and put on my minor vertices, and then I kind of draw the curve around. It's a general way of writing an ellipse. Okay, so that's the equation. You should also be able to go back the other direction too. Given the information, go back and find it. I guess I forgot to do that in this video, but we can talk about that in class.